process is the program under execution. So program, these are the this is the set of instructions, and this program it is saved in computer's memory, but it is saved onto the secondary disk, that is onto the hard disk. And whenever we execute the program, then that program it is executed into the primary memory. So primary memory means RAM and ROM. These are called as primary memory of the computer, whereas hard disk, then CD drive, after that pen drive, these are called as secondary memory of the computer. So program it is called as passive entity, whereas process it is called as active entity. So there are different attributes of the process. So these attributes of the process are called as process elements. So this is the block diagram which is representing the different elements of a process. So here we can see that the process it is represented by different attributes. For example, process ID, memory, files, registers, and kernel state. So at first, what is the meaning of process ID? So process ID, it is nothing but the identification number which is assigned by an operating system to the process. So by using this identification number, operating system it can keep track of all the processes, track of all the processes which are running on your system in the multi-programming environment. And this process ID which is assigned by an operating system, it is unique for each process. After that, the next element of the process is the memory. So this memory of the process, it is divided into 4 sections for efficient working of an operating system. So this memory, it is divided into 4 parts, and these 4 parts are text section of the memory, data section of the memory, heap section of the memory, and stack section of the memory. So see, these are the 4 sections of the memory. So when each process is created by an operating system, each process it gets its own section. So these are these 4 sections. So the first section of the process is the text section. And in the text section of the process, or in the text memory of the process, the compile code or program code is saved. Now, what is the meaning of program code, or how that program code it is saved into the text section of the memory? So normally let us consider that you have written a C program. So you have written a C program, and after that you have saved it onto the hard disk, that is into the secondary memory of your computer. And now you want to run it. So if you are using Windows and if you are using Turbo C compiler for that, then in the Turbo C compiler, for compiling that program, you will use, for example, if you are using Control F9 option. So Control F9 means by using Control F9 or compile option, you are converting the high level language into the machine level language. So when you are converting the program into the machine level language, then that machine code, it will get saved into the text section of the memory. Okay, so the text section of the memory it is used to save the compiled code of the program. After that, the data section. So data section it is used to save all the variables which are declared inside the program. So you may ask me question that if the data and program, if data and program code, or for example all the variables and the program code, if that are present in a single file, then why the variables are saved into the separate section, and why the machine code it is saved into the separate section of the memory? So for this, so this data section it is used to save the global variables as well as the static variables. Okay, so in the data section, in the data section, the operating system will save all the variables which are declared inside your program, and that variables that can be global variable and static variable. The variable is declared as a global, then we can access that variable outside the main function. Means its scope is not limited. Value of that variable, it can be accessed in entire the program. Okay. Then what is the local variable? Yes. Yes. So value of the local variable or scope of that local variable, it is limited to the block in which it is declared. So this is the difference in between the local variable and the global variable. That is, global variable you can access throughout the program, whereas local scope of the local variable, it is limited into the block or into the function in which it is declared. So this data section, it is used to save all the global variables which are declared inside your program. Static variables means value of that variables that are fixed, that values that are not changed when we compile the program or when we execute the program. So in the data section, we are saving the global and static variable. Now why here where operating system, it is keeping the variables and program code in the separate section. So for this, now let us consider that you have written a program and after that you are running it by using your, at first you are compiling it and after that you are running it. So whenever you are running the program, your operating system, it will require read permission for that program and executable permission for that program. Okay. मतलब अगर आपको program run करना है, so operating system at first it will read that program. That is, it will read the machine code of that program and after that it will execute. So three permissions are given by the operating system to each file. That is read permission, write permission and executable permission. So program code जब primary memory में run होता है, that time it will require only the read permission and executable permission. So here, that's why here program code, it is kept in the text section. Whereas let us consider the data or let us consider the variables. So here let us consider the simple example, that is the, you have written a C program to change the value of the two variables. Means here initially the value of the two variables, you have declared two variables in your program, that is a is equal to 3 and b is equal to 2. And now you have written the program to swap values of this variable. Means when you will run the program, here you are swapping the value of the variable. If the initial values of a and b are 3 and 2 respectively, so after running the program, you will get value of the variable a, it is equal to 2 and value of the variable b, it is equal to 3. Means here at the runtime, you are changing the values of the variable. Means here as at the runtime, we are changing the value of the variable, then when the operating system, it will access this variable, then operating system, it will require read access for that variable as well as write access for that variable. Means read and write permission, these two permissions are required by an operating system for that particular variable. Whereas when the program code is saved in the memory, it required only read and execute permission. But for the variable, it required read and write permission because these variables that are modified at the runtime. So that's why here program code and data code that are kept at separate section into the process memory. Next section of the process memory is the heap memory. Now, what is the meaning of heap memory? So, the heap memory, it is used for the dynamic memory allocation. So, now what is the meaning of dynamic memory allocation? So, this memory, it is used for all those variables whose memory requirements are not known at compile time. So such type of memory is allocated by the operating system to the variable and all that variables that are stored inside the heap section of the process memory. Now again, how this memory is allocated dynamically to the variables. So by using different keywords or by using the different system calls of the operating system, the memory is allocated dynamically. So different types of system calls are new, delete, malloc, free. So by using these system calls, the memory is allocated dynamically. Again, in simple terms, here we can say that when the variables are declared inside the program, and when you will compile that program. So when you will, for example, if you are using Turbo C and when you are compile it by using Control F9, that time you are converting HLL, high level language, to machine level language. So that time the memory, it is not assigned by the operating system to all those variables. Whereas when you will run that program, so when you are using the run option, so when you are running that program for getting the output of your program, that time the memory it is allocated by an operating system to all those variables. So again, I will explain you this concept by giving you very simple example, that is how the memory is assigned by an operating system to the variable at the runtime. Means that memory it is not allocated at the compile time. That is requirement of the memory. It is not known to the operating system at the compile time. It is known. It is known at the runtime. So for this, I will give you this simple example. So you have already studied the object-oriented programming language. So all of you know the Java program. So Java program it is called as object oriented programming language. So Java program it is the collection of the classes. Means by using the concept of class we can write down the Java program. And class it is nothing but the template, and object it is nothing but the instance of that class. So class it is also called as blueprint of that object. So here a simple example is given where we are creating the object of type class box. So I have not written a detailed code here. So let us consider that in the Java program, you have created a class. Name of that class is box. So this box, this is the class name of the class, which is declared by the user. And the different attributes which are associated with this box are width of that box, height of that box, and depth of that box. So you have already declared that class, name of that class is box, and in that you have already declared the three attributes which are associated with that box. And you have declared that width, height, and depth that are float type of data, that is float width, float height, and float depth. Okay. So once the class is created, now you can create the object for that class. So here I can create 100 boxes of type class box. So let us consider that here I am creating the first object. So name of that object is my box. So I am creating the object my box of type class box. So by using this, you can create the object of type class box. So here you can see that here I am using the keyword new. So this keyword new, it is used for dynamic memory allocation. That is, memory is allocated to that my box object dynamically or at the runtime. But now here, at first you tell me the answer for this. That is, by using the statement box my box, I am creating the object of type class box. So here on the left hand side of the expression, by using these two keywords, I have already created this box. But on the right hand side, again, I am using the keyword new, which is followed by box, and box it is followed by opening and closing round brackets. I will tell you very simple example for this to understand this concept. To automatically call the method name box. Yes. Okay. See, now here let us relate this syntax with one example. So a balloon without air. Suppose a balloon without air it is given to you. Now here an air it is not filled into that balloon. So if air is not filled into that balloon, then you cannot use that balloon or you cannot play with that balloon. Because if air is not there, then there is no use to use that balloon. Okay. So we can relate this example with this left hand side expression. See, this my box, it is nothing but the balloon without air. That is air, it is not filled into that balloon. So here you have a balloon with you, but you cannot play it with it or you cannot use it because up till now air is not filled into that. So by using this class name and object name, we have created the object. But up till now, we have not assigned memory to that. So on the right hand side, by using the new, suppose now for using that balloon or to play with that balloon, what you will do, you will fill air into that. So you are filling air into that balloon. So we can relate this example with this new keyword. So by using this new keyword, you are assigning memory to that object. Okay. So here you are filling air into that. So it is similar to the new keyword. After that, this new keyword, it is followed by the constructor box name of the class name followed by the opening and closing bracket. So now why this class name is again written twice in this statement? So for this, suppose now you have filled an air into the balloon more than the capacity, then your balloon it will get burst. And if you will fill the air less than its capacity, then you cannot play or you cannot use that balloon neatly. So now I can relate this example with this. Now here I am using the constructor name of the class here. So I have already declared this class box in my program, that is class box, and three variables are associated in that, that is width, height and depth, and I have declared data type of that variables, it is equal to float. So I know that how much memory is required to save that box into the memory. Okay, because I have already associated the three attributes along with the box. So here we are passing the name of the class again. Why? Because here it will tell the Java interpreter that how much memory will be required by the particular object to save it into the memory. So that's why here we are using this name of the class two times in this statement. Now the last section of the memory is the stack memory. So the stack memory, it is used for the local variables. Local variables means suppose you have declared a is equal to 3 and b is equal to 5 inside the function, then that value of the variable it is known to that particular block only. So such type of variables are saved into the stack section of the memory. Okay. So these are the elements of the process memory. After that, the next elements of the process that are, so we have studied what is the meaning of process ID. After that, how the process memory it is divided into different sections. Then next section of the process is file. So files it is nothing but the file descriptor. So this file descriptor that are used to save the permissions which are associated with that file. For example, read permission, write permission and executable permission. That is, if only read permission given by an operating system to that file or by the user to that file, then you cannot write that file. That is, you cannot modify that file and you cannot execute that file. If read and write permission is given to the file, then you cannot execute that file. So all these permissions are kept by an operating system into the file section. After that, next section is the register section. So the kernel keeps track of process memory using registers. So all these registers that are stored into the memory. Now what is the meaning of this register? So registers that are nothing but the temporary storage locations. So temporary storage location means, again we will take the example here that suppose you have written a program in that you have declared the value of a, okay, value of the variable, and that value of the variable that is a, it is equal to 50, and after that you are taking the number from the user, and after that you are matching the number entered with the user along with the value of the variable which is already saved into the memory. So you have declared a is equal to 50. After that you are asking the user that enter the number. Okay, so when you have declared a equal to 50, so that a equal to 50, that number, it will get saved into the register or into the temporary memory. After that, you are asking the user that is enter the number. So when you are asking the user enter the number, that time your process, it will require the input resource because the number is entered by the user through the keyboard. So whenever you require the input resource, that is keyboard resource, that time your CPU is idle. CPU is doing nothing because now you are asking the user that enter the number and you require the input resource here. So in that case, in the multi-programming environment, your operating system, it will assign your CPU to another process because here the currently the process, your process is running into the memory and it is asking the user the input, that is it is using the keyboard. So that time the CPU it is assigned to the another process. So in that case you have already declared the value of the variable a, it is equal to 50. So that 50 it will get saved into the temporary location. Though you are using the input resource, though you are using the keyboard, your value equal to 50 that will remains as it is into the primary memory into the temporary location. So this temporary memory it is nothing but the register. state of the process is the kernel state. So all the interface in between the user and hardware. So by using this kernel state of the process, your process it interacts with all the machine parts of your computer. All the machine parts means all the input devices, output devices, processing unit, okay, and memory. So this is the kernel state of the process. So these are the different elements of the process.